use this template now to solve all of our series program. Now let's look at some basic series and see how to solve them. First basic type of series is arithmetic series like these. Why are they called arithmetic series? That is because the difference between each term is the same. Like in the first series, each term is getting incremented by 1. Second is getting incremented by 4. Third and fourth are getting incremented by 2. And last one is decrementing by 1. To solve any of these, we will first get the template we just created. We will declare the sum variable and initialize it to 0. Next, we will input the value of n from the user and it will be typecasted to int. Next, we will set up the for loop using a range function to run the loop n times. Inside the loop, we will have sum is equal to sum plus term. Once we are finished with the loop, we will write the print statement to print the sum. Now let's learn how to use this template. Let's start with the first series. In this we are adding 1 with 2 and then 3, 4 till n. Now if you know a little bit of coding and are familiar with range function, you might figure out that index I is actually already taking on values from 1 to n in this loop, and you can actually solve this by just writing sum is equal to sum plus I in the loop and you are done. But the moment the series start getting complex, like here, and you start changing the values in the range function to match the terms of the series, it is no longer adding n terms of the series and your whole answer goes for a toss. So I recommend not to touch the range function. The job of for loop and range is only to run the loop n times so that we get an opportunity to add n terms of the series. We will use a new variable a to represent each term of our series. A will have an initial value of whatever is the starting number of the series. Like in this case, it is 1. Inside the loop, then we will just add a to sum every time as a is our term. Then we check what is the each term of the series getting incremented by. Here the series is incremented by 1, so I will add a plus is equal to 1 to get the next term of the series for the for loop. Now let's see how it works. Let's say the user enters n as 5. The range function ensures that this loop runs 5 times. That's its only job. Variable a takes on the responsibility to form each term of the series. It starts with 1, which is added to the sum. Then it is incremented by 1 and in the second iteration, it is added to sum. Then it is incremented again by 1 and in the third iteration, it is added to sum. This continues for 5 iterations and then we get a final value of sum to be printed. This completes the first series program. Now what if we are doing the second series 9, 13, 17 till n? How does this program change? There is no change in the template. This time we will assign 9 to a as the starting value of the series and then just do a plus is equal to 4 for each iteration of the loop. For each iteration, a will take on the value of the term of the series and get added to the sum. This solves this series program. Let's see next one. Here the starting number is 2 and it is incremented by 2. So we will just set a is equal to 2 and increment by 2 every time. This is the program for this series. In the next series, the starting number is 1 and it is incremented by 2 every time. So we will just change the starting number to 1. Now next one is decreasing numbers, so we will set the initial value of a to 10 and then do a minus is equal to 1 every iteration. This is the program for this series. Now this sounded so simple, but you might say that the series which I get to solve look way more complex, something like these. If you look carefully, all of them have arithmetic series as base. Just that each term is presented in a bit complex manner. All we need to do is now build each term as given in the question. Let's see how we will use the same template for these series too. Since the first series has x2, we will take in that too from the user. Now let's see how we will form each term to add to the sum. In the first series, we see that the power number is an arithmetic series starting with 1 and incrementing by 1. So what we will do is first just add another variable a before the for loop and initialize it to the first number of series, which is 1. Then inside the loop, we will create individual terms as per the series given in the question. Here it is nothing but x raised to the power of a. So we will write sum is equal to sum plus x raised to the power of a. After this, we will increment a by 1 inside the loop to get the next value of a. So this is our program to find sum of this series. Now let's solve the next one. This too requires us to input both n and x from the user. Here we see an arithmetic series starting with 9 and incrementing by 4. But here we have the factorial of each number of the series. So this time we will initialize a to first member of the series, which is 9. In our for loop, we need to find the factorial of a as our term. So we will import the math library and use math.factorial a to form each term of the series. We will then do a plus is equal to 4 to get it ready for next value of a. This gives us the program for this series. Let's solve the next one. Here we know n is 10, so we will directly assign n is equal to 10. Here we see arithmetic series starting with 2, so we will initialize a with this number. Inside the loop, we will form the term of the series, which is a raised to the power of x to be added to sum. Then we will increment a by 2. This is our program for this series. Now let's see the next one. Here we take in both n and x from the user. Here we have an arithmetic series starting with 1. So we will initialize a with 1. Inside the loop, we will now write each term as sum is equal to sum plus a raised to the power of 3 divided by x. Then we will increment a by 2 to get the next value of a for the series. Let's see the next series. Now this is an interesting one. It has two arithmetic series. Numerator has a different series and denominator has different series. How do we solve this one? It is equally easy. Here in our template we know n is 10, so we will assign it directly. If there are two series, we will just take two variables, first a for numerator and assign it to starting value, which is 2. We will take another variable, let's say d for denominator, and assign it the first number of the second series, which is 10. Inside the loop, we will just form the term exactly as it is given in the question. Sum is equal to sum plus a divided by d. Then we increment a by 2 and decrement d by 1. This gives us the program for this series. Using this logic, you should be able to solve any series which uses arithmetic progression. Now let's see another type of simple series, geometric progression. In this, every term is derived by multiplying the previous term by a fixed number. Like the first one is getting multiplied by 2, second and third are getting multiplied by 3, and fourth is getting multiplied by 5, and so on. To solve any of these, we will first get the template we created earlier. Now let's learn the key part on how to find the sum of these series. Let's start with the first one. Here in this series, the starting number is 2 and the next number is obtained by multiplying the previous number by 2. So in this case, we will take a variable k for each term of our series and initialize it to 2, which is the first number of our series. Inside the loop, we will just add our term k to sum for each iteration. This time, to get the next term, we will do k is equal to k multiplied by 2 for the next iteration. Now this will every time multiply the previous number by 2. So if a user enters n is equal to 5, the loop will run 5 times and k, which is our term, will start with 2, then it will get added to sum. Then it is multiplied by 2 to get the next term, which is 4. Then the loop will repeat and it will get added to the sum, and then again multiplied by 2 to get 8, and then 16, and then 32. Every time it will get added to the sum, so the sum value will be 62, and this is our program for the series. Let's look at the next series. This is a geometric series with a starting number of 2, and every term is obtained by multiplying the previous number by 3. We again start with our standard template. In this we assign k to 2, which is the first term of the series. Inside the loop, we will add k to sum, which is sum is equal to sum plus k. Then we will add k is equal to k multiplied by 3 to get our next term of series. This is our program for the second series. Similarly, we will solve the next series, which has a starting number of 10, and each term is obtained by multiplying the previous number by 3. So in the template, we will first assign k to 10 and then do sum is equal to sum plus k, and then k is equal to k multiplied by 3 inside the loop. This is our program for this series. Last one is also similar. We will first assign k to 5, which is the first term of the series. We will then do sum is equal to sum plus k, and k is equal to k multiplied by 5 to get the next term inside the loop. This is the program for this series. Now this sounded so simple, but you might say that the series which I get in exam look way more complex. Something like these. Let's see how we will write the program for these. We will again start with our standard template. Let's start with the first one. Since this has x, we will take in x also from the user. This has a geometric series in the numerator, so we will add variable k and initialize it to the first number of series, which is 2. In our for loop, now we will form the term as per the question, which is x divided by k, which we will add to the sum. Then we will add the statement k is equal to k multiplied by 2 to get the next k to form the next term of the series. This is our program for this series. Let's solve the next one. This one has one thing different, which is that alternate numbers of the series are negative. I will show you now how you will solve this, and you can apply the same logic for any series with alternate negative number. So we start with our template and we first initialize k to 2, which is the first number of the series. Now if you look at the series closely, you will see that the numbers at odd positions are positive and numbers at even positions are negative. So what we will just do is that inside the for loop, we will just check if I is even or odd. If it is even, we will subtract from sum. If it is odd, we will add as usual. Then we will add the statement k is equal to k multiplied by 3 to in the loop to get the next term of the series. This is the code for alternate sum and subtraction, and this logic can be used for any series. Let's solve the next one. Now this has two series. One is arithmetic series in the numerator and geometric series in the denominator. How do we solve this? We will take our template and for each series we will declare a separate variable. So we have two variables, one a which we will initialize to 2 and k which we will initialize to 10, which are starting number of each series. Inside the loop we will form the term exactly as it is given in the question, which is x plus a divided by k. Many of my students in a hurry to solve this forget to put the brackets. If you forget it, you will get a completely different answer. So always remember to use brackets when there is a division. Then we will put the statement a is equal to a plus 2 for the arithmetic series and k is equal to k multiplied by 3 for the geometric series to get their next term. This is our program to solve this pattern. Let's solve the last one. Now this has three series. Let's take our template and try to solve it. For each series, we will take separate variables. So we will take k for geometric series in the numerator and initialize it to 5. In denominator, we have arithmetic series, so we can add two variables, a1 initialized to 1 and a2 we will initialize to 2, which again are the starting number of two series. Inside the for loop, we will form the term exactly how it is given in the question. Here, since we need factorial, we will add the import of math library and then form our term, which is x multiplied by k raised to the power of 2 divided by a1 plus math.factorial a2. Here again, do not forget the brackets. This term is added to sum. After this, we put in statement to get the next term of each series. It is k is equal to k multiplied by 5 for geometric series and a1 plus is equal to 1 and a2 plus is equal to 1 for arithmetic series. This completes this program and our lecture for the day. Now the series program can also be solved very easily using the nth term equation for arithmetic and geometric progression. I am not explaining that here, but we will keep it for some other video. If you have any doubts, you can always reach out to us at simplycoding.in. Thank you and all the best.